Hello class, good day. Welcome to our module 14, which are only the additional problems on normal and tangential components. So additional problems lang ni siya sa atong previous nga discussion on module 13. Okay, so we have here our sample problem number 1. So the block rests from at a distance of 2 meters from the center of the platform. So we need to take note of this, no? Ang first niya gibutang diri kanisya nga block is at rest. So initial velocity is 0. And then its distance from the center of the platform is 2 meters. So since iyang pagtuyok ani is like this, that is counterclockwise, that is horizontal nga motion, di siya vertical. Then and then this is the center of, or we call this the axis of rotation. Therefore, kung ato isulat ang given, ang first nga given nato is that we have here nga the radius of curvature, the radius of rotation is 2 meters. Then what's next? We have here, if the coefficient of static friction between the block and the platform is mu s equals 0.3. So ato ang coefficient of static friction is 0.3. Then what we were asked to determine the maximum speed which the block can attain before it begins to slip. Assume the angular motion of the disk is slowly increasing. So the maximum speed, or Vmax, just before the block begins to slip. So how do we solve this? Again, if you notice, natay coefficient of static friction in our previous examples, we have the coefficient of kinetic friction. So what's the difference? So the coefficient of kinetic friction, so namatay friction, diba? So natay static and kinetic. So kinetic is mo siyang friction that acts upon the object while the object is in motion. So here, the object is stationary. So while gatuyok ni siya, gapundor gyud siya diri, wala siya gina-push or wala siya ga move. So ang coefficient of kinetic friction and then the coefficient of static friction, na sila relationship. But ang maximum nga value ni coefficient of kinetic friction should be equal to the coefficient of static friction. So mo siya ang coefficient of static friction just enough nga the object will not will not move at a certain force, and then while it is being stationary. So ang katupong kinetic is mo to ang friction while the object is moving. So more na yung difference is the static is katong stationary, friction is stationary ang block, and then the kinetic is while the block is moving. And then you were asked determine the maximum speed with the block which the block can attain before it begins to slip. So again, I just want to review our previous topic. So di ba? We have the kung nata rectangular components on x, y, z. Here we have the normal, tangential, and then the added binormal component of motion sa particle. So if the particle is moving, we can have, if we take the scalar quantities of each motion of the particle, we have the normal, di ba? If you remember. And then we have the tangential, and then the binormal component of the force. So there is an acceleration on the normal and tangential component, but no acceleration on the binormal component. So the following Newton's second law of motion, the summation of forces along the normal component is equal to the mass of the particle or the object times the normal acceleration of the object. And then the tangential forces is just equal to the mass times the tangential acceleration of the particle or the object. And then for the binormal component, mura gyud po na siya mass times acceleration. But since there is no acceleration along the binormal component, that is just equal to 0. So kung ma-0 ni m times 0, that is just equal to 0. So kaning normal component of the acceleration, if you remember, that is just equal to the square of the velocity of the particle over the radius of curvature. So same lagyan pa ng application aning normal acceleration of the objects from our previous example. So again, take note that the rotation of this object is along the horizontal. So this object has three components, di ba? So we have the what? So we have the binormal component of this object. We also have the normal component of the motion of the particle, and then we also have the tangential component of the motion of the particle. So unsa man atong gamiton to analyze the motion of this object. So without saying this, so let's say if we look at the top view of this object, so this is the path of the object, horizontal nga motion, and then that is 2 meters, and we have the object here. We have the tangential acceleration on that side, and then the normal acceleration on that side. So using this object, let's first draw an FBD of the particle with the normal and tangential components of the particle. So atong gigamit isang normal o tangential nga component. So kani once nga naman rectangular components ani but normal, tangential, and binormal, you can use kung unsay mas maayo nga makasolve. So we have the normal, tangential. You can also use the binormal and the normal, and then the binormal and the tangential. It depends kung unsay mas maka-benefits ato sa pag-solve. So this is the normal axis and then the tangential axis. Acceleration of the normal is always towards the center. Acceleration sa tangential is always outward. So, ang expected na ito nga kani siya nga object is malabay siya outward. So, we have the force which gatro siya pagawas. So, let's name that force only as F. And then, naapoy friction, no, denoted by Fs, nga gaak ani nga object. So kaning force nga ga push siya pagawas, this is the mass times acceleration. Select the reverse effective force. No, so if that is the acceleration, and then this is the reverse effective force. So we have the unsa pa may given na to. So we were asked the velocity, and then here on the tangential acceleration, so if this is the mass, it moves that way. Actually kani siya malabay ni siya on this side, di ba? Pagawas. So perhaps na force diri, let's say we call that Ft, and then ada po friction. So between the two summations here, asay mas dali na to magamit. So if we use M80, so kung makuha na to si acceleration of tangent, unsa may magamit na to, we cannot solve immediately for the velocity. We can use other but among the formulas here and among the solutions here that we can see, ang pinakadali ra gyud nato gamiton is katong summation of forces along the normal components. So muna siya summation of force na siya along the normal component. Here's a sample. So summation of forces along the normal component is equal to mass times the normal acceleration. So yes. So we have the friction is equal to the mass times the normal acceleration. So kani siya unbalanced force, this is the mass times acceleration. So our frictional force is equal to 0.3 times the weight of times the normal force of the object is equal to m v squared over the radius, which is 2 meters. Again, unsa man pila man si normal force along the of this object. So the normal force of this object is, kung yung tanong, there is no other forces nga nag-act diri, that is just equal to the weight of the object. And we know that the weight of the object is equal to the mass times the gravitational acceleration. So muna na ito i-apply dire. So we have the 0.3 times the mass of the object times the gravitational acceleration. This is an SI unit, so that is 9.81 meters per second squared is equal to mass times the square of the velocity over 2 meters. You have the mass here, so makancel sa left and hand. And then you have the v squared equals, so ato lang ni i-cross dito nga side. You have 0.3 times 9.81 times 2. So v squared is equal to 5.886. So our maximum velocity just before the block began to slip is equal to 2.426 meters per seconds. Like this one. So actually, pwede ra gani gyapon ninyo gigamit ang binormal and the normal component. Para di na mo malibog ang binormal component, we only have the mass acting, so yeah, ang weight and then the normal force. Maura. So here naapod tay sa along the tangential component, naatay katong force sa friction and then katong reverse effective force sa object. So to present you nga unsa itsura niya kung this one the binormal and normal component. So yung ani ra gyapon yung FBD for this is the normal axis, this one, and then the binormal. So mo rin iyang representation, this is the normal force and then this is the weight of the object. And then we have the friction nga gapugong siya, and then we have here the acceleration. So we have a reverse effective force here going outside. So this is F. This one, the REF, which is equal to mass times the normal acceleration of the object.